Hello guys. Namaste, Parev, Dumelang, Huyamor, and Bonani. I hope you are all okay. So today we have some symbols and some signs, symbol signs and some readings that we have to explain that you will see in laptops and as well as in schematic. So you have to understand all these readings, okay? First of all, this is a sign of a resistor. I hope you can see the sign of a resistor, and it's represented as R on the motherboard, and this is the diode, of which is represented as D on the motherboard, and we have a capacitor, and this form of a capacitor is a ceramic capacitor. It's represented as C on the board, and we have a crystal, of which is going to be represented as Y on the motherboard. You will have inductor or coil, of which is going to be like this, and it's going to be L on the motherboard. Let's go ahead. I'm sure you have seen this on the schematics. Don't be confused. The first sign there on top, the one pointing down, two of them, they mean this is the ground. That's the ground symbol. Okay, and the second one, the symbol, this one, it means the signal is going out. The signal is being sent out. For example, when a startup chip or a super IO chip, it's saying all the powers are good, give that signal out, right? Or it's received that signal in. So here, sorry man, this is a signal. Wait. Now, before I get confused, oh, this signal is going out. Yes, sending this signal out. All right. For example, when the VRM, the CPU VRM is good, it's working 100%. Gonna send out a signal. There will be an error going out, going straight into a super IO chip, saying all the power are good, and the super IO chip would receive that signal as this symbol, meaning it's going inside the super IO chip. All right, and then this one is a T junction. It means wires are connected there. It means it's interconnection, the intersection there. And there, it means this one here with a circuit, it means the signal is going to some other places. Okay, it means still continues to some other places. And then this one here, you use a common sense as well. It means it simultaneously exchange what the information in and out. Okay, let's move on. There we go. This is a big problem. You have seen this a lot in the schematics, and you end up being confused. You don't know what does it mean, all those things. The first one is clock power code. After the South Bridge receiving the VRM power code, this means VRM power code. Okay, VRM is the CPU power supply. It means that it's called the VRM power code. Okay, I was reading this after the South Bridge receiving the VRM power code. Remember, this VRM power code is coming from where? From the VRM. VRM sent the signal out saying, hey guys, I'm okay, I'm good, you can start up. Send the signal straight, okay, to do what? As a high level for opening what? For opening a clock. Let's move on. The G792. This one, you won't have it as a G792, depending on the board that you are repairing. Oh yes, as we spoke about the OEM, different type of manufacturers. Some they won't name this as a G792, all right? But this signal is for what? It's for temperature control chip. When the temperature is normal, it sends this signal. Okay, the clock enabled. This one is mean the CLK. This one here, CLK, means clock enable. Okay, we have to enable what? The clock. How to enable the clock? After a CPU power supply is being normal, send the low level that can be used to open what? A clock. Because guys, almost everything on the board is need to report saying I'm okay. Go ahead, proceed. Do this, do that. Alright. Let's move on. This is lead close. This one, when you are closing a laptop and opening the laptop, the thing that lead is consent. Okay, when it sends this signal lead close where? To a startup chip. Alright, KPC power budget. All right, when you're pressing the power button, it's trigger what? The EC. The EC means embedded chip. That big chip, the startup chip. There's a signal going there. AT in or AC in. Okay, adapter in or AC in, the same thing. All right, the power adapter detection. Okay, it's detect the power adapter. And even this one as well, it goes where it goes to a startup chip. Almost most of the signals here, they go to a startup chip. This one here goes to a startup chip. It needs to report. They tell you guys the adapter has been connected to where? To a startup chip. And to where? To a charger chip as well. Okay, let's move on. V 5 volts always right. This is standby for South Bridge. You see this power S5 enable the control used to open the standby voltage for what? For South Bridge. Powers S5 enable. ACAV in adapter detection output for charging chip. Alright, as I've said before, depending on the OME board, so this will be written as a different thing, but depending, you'll use your common sense and be able to read these signals. Okay, AC in, like I'm saying, this means the charger has been connected, the charger input chip, this power supply input for charging chip. This one AC in, this means adapter detection has been input. This one DC in, it's a power supply input for what? For charging chip. The charging chip will receive this power as a DC in. Right, 3.3 linear power supply. This is a reverse. Okay, to where startup chip. But again, it depends on an OME. Dissipates out common point. 80 plus voltage power supply that will convert. All right, let's move in. Voltage adapter, power adapter. Okay, this is 19 volts. Adapter enable power adapter enable active low. This is a power adapter enable signal. Adapter present. This one means adapter present. Adapter enable, adapter present, voltage adapter. These are all the 19 volts adapter detection. V battery, this is a common point for a battery, 3.3 and 5 volts linear power supply. Okay, this is a linear power supply. It means it's always on. Even this all, it means always on. The 3.3 always on. 5 volts always on. All right, power switch. Okay, signal simple. Okay, USB power. We did this as well. OCP. OCP means overvolt current protection. Limit signal. Power adapter connector. Identify. Okay, 3.3 volt power supply for standby system. Okay, VCC port. Initially resetting. Okay, guys, this is the initially reset of EC of a startup chip. When you see this VCCI, you should know that it is the initially reset for what? For a startup chip. Suspend state. Okay, this indicates that the system will be power on, down, power save mode. Okay, hope you can see suspend. We'll talk more about the suspend. Okay, the front side bus clock signal. Okay, bus clock. Okay, ICH power. Okay, this is the power over the South Bridge. Inform the South Bridge voltage. Power is good. ICH power good. You can see as well. ICH is report. Say, yeah, you guys, I'm okay. V gate, voltage gate. Okay, CPU core voltage power code signal. Okay, CPU core, this is a power supply for a CPU. This is a power for what? For a CPU. VCCP, this means the working voltage of CPU. Suspend. Okay, let's say the USB ports. Let's say you connect a charge on your laptop, right? The screen won't receive any power. You know that, right? The power that comes after pressing the power button as suspend voltage. You'll see this suspend. This one means the next one means system is on. And it's S3 ray. S0 it's when the system is off. S3 on. power button out. This is a trigger sent by standard chip to the salt button, meaning the power button out. Yes, on and off. Well, I don't have to tell you this. This is an on and off button. Even this one on and off button. The pointer always. I've mentioned this before. VL 5 volts linear power supply. Power AC detection for adapter. B plus common point. B plus is the 19 volts. When you see this, just know that it's where you'll find what the main power rail. All right, just to make it easier. Okay, one wire enable. This is for Apple, SMC. Okay, SMC PC. Okay, this is for Mac, book. But anyway, it's fine. We can go through it as well. One wire enable. This is to enable what? The one wire to give you the green light on the oh, you know what? Let's just do another lesson for a MacBook. Wait, should I do another one or should I continue with this one? No, let's do another one.